In this video, we'll go over the phase diagram. So in this diagram, we've got two things. One is changing temperature, and the other is changing pressure. The things we've been looking at are what happens when you change temperature. For example, let's say we start here in the solid phase. So solid is on this side of the line, the solid lines. So the solid, if I increase the temperature, it will change to a liquid. So this would be the melting point. So when you cross this green line to the right, you're melting. If you cross it going to the left, that's freezing. If you increase the temperature of a liquid, you'll reach the point where you cross into the gas. So crossing this line from liquid to gas, this is boiling, or condensing if you go this way. So you can also see that, for example, if you have a gas and you want to change it to a liquid, you could increase the pressure instead. So if you increase the pressure, it will increase pressure until it changes to liquid. If you further increase pressure, it will eventually change into a solid. So changing temperature is one way to get things to change phase. Another way is to change the pressure. A couple of interesting things here. One, this triple point. At this point, solid, liquid, and gas can all exist in the same material. Here, you can think of this line as being the point where water boils. So at that specific temperature and pressure, you've got gas bubbles inside the liquid water. So gas and liquid together. Down here, you can have gas, liquid, and solid all at the same time. Below this point, we transition directly from solid to gas without ever having liquid. An example of this is carbon dioxide at atmospheric pressure. So at atmospheric pressure, solid carbon dioxide is called dry ice. And the reason it's called dry ice is because as its temperature increases and it changes phase, it doesn't create liquid. It goes directly from solid to a gas. I think that's called ablation. I need to look that up. All right. Out here, there's another thing, the critical point. Beyond this point, there's no boundary between liquid and gas. So at these high pressures and high temperatures, there isn't a clear distinction between when something changes from a liquid to a gas. Also, we have this dotted line here for water. And if I draw a vertical line here, you can see that water goes off to the left, liquid goes off to the right. So that means here, keeping the same temperature, if you increase the pressure on ice, it will change to liquid water.